Hello everybody, welcome back. Carl again. Today I have some kind of exciting news. I have a new product which I'm really excited about. So this is from Whitebox Labs, and let me just open it up. Now I already pulled the packing peanuts out. So in here is the Tentacle shield. And so let's open this up. This is the first time I've actually opened this shield. Okay, so what is this? This is an Arduino compatible shield with galvanic isolation on each channel. So each one of the BNC connectors. So you can have pH, EC or electric conductivity. That's basically your salinity level, dissolved oxygen, and ORP, or any combination of those. So you could have 2 pH probes, 1 ORP, you can have 4 pH probes, etc. And they're all galvanically isolated. Now, I've done a video before about my pH shield that I'm currently using with my Arduino controller, and one thing I liked about that is that it had galvanic isolation. Now, prior to me actually using that shield, I did some research and I did look online, and I found from Atlas Scientific this little device right here, which is called a pH stamp. Now, what I liked about the pH stamp was it's really, really tiny. I mean, look how small that is. So I like that. Now, the problem when I got into looking for a pH, the problem that I didn't like was with the Atlas, you have to have an external controller. So when you buy the pH stamp, this is literally all that you get. Now, just as an example, here is a dip socket, and this is a dip 18. And so we'll just put this right over top, and you can see it's about the same size as a dip 18. So when I started looking, you have to buy a separate adapter board from Atlas. So you have to buy the pH stamp, and then you have to buy some kind of adapter situation. They weren't galvanically isolated. And ultimately, I want to have electric conductivity, which is my salinity level. So you have to buy an EC probe, which is pretty expensive. They're about $115 for those probes. But now with this Tentacle shield, it's all ready to go. There's 4 BNC connectors and 4 galvanically isolated channels. So as you can see, they're just the simple shield headers. And I'll have to solder them in, of course, which is fine. And these are stackable, so I'll just stack this right on top of my Arduino, and then I'll have 4 galvanically isolated channels. The other thing that's nice is you can see here that's actually built to have those Atlas Scientific stamps plugged right in. So you buy the Tentacle shield from Whitebox Laboratories, and then you go to Atlas Scientific and you buy the pH stamp, the ORP stamp, the EC stamp, or the dissolved oxygen stamp, and you just plug that into the board. And that's it. And then you'll have your embedded code. Now, of course, Atlas Scientific has great open source code as far as the Arduino goes. They don't open source this. Now, on here is a bunch of circuitry with a PIC microcontroller, and of course, they don't tell you how this works. But this works on serial data or I2C, which is another plus. When I was originally looking at the Atlas stamp, they did not have I2C, and I did not want to run serial. Now this is I2C compatible, so you literally will just plug this in. You can set the I2C address in the code, and then you're ready to go. The Tentacle shield from Whitebox Laboratory actually does come with some example code, and that's what I'm going to use in the beginning, is just their quick and dirty example code. The only thing you have to have after you buy the Tentacle shield is, so you have to buy the stamp from Atlas Scientific. You also have to have a probe. Now, I cannot recommend that you buy a cheap $8 eBay probe from China. They are garbage. You'll have tons of problems getting them calibrated. If you do get them calibrated, they're hard to stay calibrated. I just can't recommend that. Spend the 35 or 50 bucks and buy a good quality brand pH probe. If you don't think that the lab grade probe is necessary for your application, just buy a quality pH probe from the one I bought is from American Marine, and they make the pinpoint pH monitor. Okay, so I am at whiteboxis.com/tentacle/docs. So if we go to Whitebox Labs, this is their homepage, and it talks about the Tentacle Shield for Arduino and Atlas Scientific devices. You can see here you have all four probes, or excuse me, all four stamps mounted in the Tentacle Shield. And we're just going to go up here to Tentacle Shield on the top right, and then go down to documentation. Now, one thing I did not mention is that it comes as part of the package. You get standoffs that look like they're the proper height to allow for the Arduino. You get rings so that if you want to mount the BNC connectors in an enclosure. Also, the stamp that I have is the Easy stamp. I have it mounted in. You have these jumpers here, which are used to set I2C in serial. So I have mine set as I2C. And then down here on the right, if you're using serial, you can actually stack 2 of these shields together to have 8 possible combinations. So you can actually use this jumper here to set serial 0 through 4, which is Arduino pins 4, 5, 6, 7, 10, and 11. So that's all. It just allows you to set those serial channels. So for me, I'm just going to remove it because I'm using I2C and I'm not going to need it. If you look at their documentation page, it talks about that jumper again is the serial jumper. You have the I2C. This is where you put your stamps at. We'll scroll down. It talks about prerequisites, what you need. You need a Tentacle Shield, an Arduino, and then an Atlas Scientific sensor, and then the required probe. One thing that's kind of neat is the Tentacle Shield works with all of these connectors, the Easy pH stamp, and then the legacy models 5, 4, and 3. So Atlas's new range is this Easy setup, and it just makes it a little easier getting running. It talks about some example sketches here, which I'll open up in a second. Gives you the option to serial or I2C. Gives you a warning about don't touch the sensor or the shield while you're measuring circuits. Can cause electrical interference. And then it tells you how to set the jumpers correctly. And then the UART channel select group. So I have to say, all in all, I'm very well impressed, and I'm super excited because I've been kind of at a stalemate on where I go from now on my Aquarium computer. Like the major companies, the Reef Keeper and the Apex, you have other options you can keep adding. But for me, I was kind of stuck. And now that I found this board, I can have ORP, which some people like. I really like the electric conductivity, which is my salinity. And then I have a pH. And they're all isolated from each other. So I'm really excited about that. Okay, so the first course of business is to set the Atlas stamp to I2C mode. So it comes default set up in the UART mode. So it gives you 2 options. You can do it through serial port, through the UART port, which switches to the I2C. But I'm going to do it the easier way, at least in my mind. Manual switch and I2C. And so what you do is you simply provide power and ground. So the blue wire here is ground, and that's going to the top ground pin. This wire over here will be my VCC. And then this white wire connects the P ground to the TX pin. So up here, just real quick, the directions. Take the power off, disconnect any jumper wires. Short P ground pin to TX, power the device on, and then wait for the LED to change. And this will set it in the default address state of 99 or 0 time x63. So let's come back down here, and let me just connect this to VCC. Let me double check my connections, and then I'll plug it in and see what happens. So there it went. It went from green to blue, and so now it's set. So I'll unplug it, and I'll take my jumper wires off, and then I'm going to take the pH stamp and plug it back into the Tentacle Shield. Make sure you double check your polarity. You don't want to get this in backwards. Okay, so now to the Arduino part. So here under the Whitebox Labs website, you'll see there's two examples, Tentacle setup and Tentacle setup. I am using an Arduino Uno Rev 3, so I'm just going to stick with the Tentacle setup. When you open that up, this is the sketch you're going to get. Now, if you followed along the first part and you set your default state to I2C, which is what I'm going to assume you're doing for the purpose of this video. So I've set mine to the default state of I2C based upon the data sheet from Atlas Scientific. Now, what we're going to do is if we scroll down to calibration here, we talk about this are the commands that we have to send. So you have to do cal, clear, that clears all the data, and then calibrate, mid, and then your pH. Now they recommend that pH 7.00 be your starting point. Now it could be 7.01 or 7.02. That's okay as long as it's a floating point value that represents the midpoint. And they recommend around pH of 7. So in my sketch, I have the Tentacle setup uploaded. I'm going to open up my serial port. And it tells me what to do. Now, for me, I'm going to do 99 because that's the default state. So I type 99 and then I hit enter. And you'll see it says change in channel 99, command failed, acknowledge. And then at the bottom here, it says active channel 99, type PHEZO, revision 1.9, communications I2C. Also down here at the bottom, I have a carriage return and then 38400 is the baud. And that's just what the sketch calls for. I go there, let me just show you my setup. It just so happens to be, you see I have my cable here running on the floor. So I have the pH probe in the fish tank. Here is the Arduino Uno, the USB cable running to my PC, the Tentacle shield, and then you can see this is my pH probe. Now that's running here to the aquarium. So what I'm going to do is I'm going to take the probe, I'm going to dip it in some clean RODI water, and then you can see there's my pH 7. And I like to leave it in the aquarium so that it keeps this temperature of the solution at about the same temperature as the aquarium. That way when I'm calibrating it, it's on par with the temperature of the water. Now there is a section in the datasheet for the Atlas stamp that says you can do temperature calibration. But for my purposes, it's never that far apart because my solution is usually about the same temperature as the water. So I'm going to set my phone down just 1 second so I can rinse the probe and then put it in pH 7 and I'll be right back with you. Okay, so just in case anybody wonders, this is Atlas Scientific pH 7.00 solution. I also have 8.00 and I have over here the 10.00. So I'm going to use this as my midpoint, and then I'm going to use the 10 as the high point. And now I'm just going to do 2-point calibration. Now, Atlas does recommend 3-point, and unfortunately I don't have any 4. So probably the best solution would be to use the 7 as your mid, the 4 is your low, and the 10 is your high. Okay, so I'm going to run through the calibration procedure, including temperature compensation. I have the phone position here. Hopefully you can read what I'm doing. So the first thing to do is type 99 and then press enter. That'll actually take me into that channel. And then I'm going to do cal, clear. You can see that's acknowledged. And all of these commands are in the Atlas Easy data sheet, which I'll link in down below. The next command is T, 25.5. T is the temperature, and then the 25.5 represents the temperature of the fluid. So I know from past experience that mine is about 25.5 degrees Celsius. So I'll hit enter. See, I get an acknowledge. And then I'll do cal, mid, 7.00. That's the actual exact calibration of my fluid. And then I'll press enter. You can see I get a command pending at acknowledge. Now I'm going to take the pH probe out of the 7 solution, place it in the 10, wait about 5 minutes, and then I'm going to calibrate the high point. So I'll be right back with you for that. Okay, so it's been about 5 minutes since I put the probe in pH 10. So now I'm going to calibrate it for the high. So it's cal, comma, high, comma, 10.00, and then enter. And you see command pendant, and then acknowledge. And that's it for the calibration. Now I am ready to actually get the pH. Okay, so in the datasheet it talks about quick codes, and if you send it in R, it just takes a single reading. So what I'm going to do in the thing, I'm just going to type R, and then hit enter. And then you can see that it actually gives me an acknowledgement, and then it's telling me a pH of 9.999. Now, it's still in the pH of a 10 solution, so that's pretty accurate for my purposes. The difference, in my opinion, is probably going to be the temperature change. My solution probably isn't exactly 25.5, so that's where you're getting the least significant digit off. And I have to say, for an aquarium, a pH of 9.99, if it's really in 10, is pretty daggone close. So what I'm going to do is rinse the probe off, and I'm actually going to stick it back in my aquarium water and see how close it is. Okay, for me, prior to switching to the Tentacle Shield, I was using my existing pH circuit that I had, and it actually gave me a reading of 8.55. And because I knew I was getting the Tentacle Shield, I actually calibrated that just a couple of days ago. So is it really that high? I don't know. But what I'm going to do is, I know my baseline was 8.55. I'm going to rinse my probe off in my RODI water, and then I'm going to stick it in the aquarium. I'm going to give it a couple seconds, and then we'll see what it actually reads. So once I get that set up, I'll be right back with you. Okay, so the pH probe has been in the aquarium now. As you can see, I just did a R command. I'll do another one. And it actually gave me a pH of 8.56. Now it just gave me 8.57. So the Tentacle Shield is spot on in my mind to the prior pH shield I had, which I became pretty confident with. So I'm very confident with the Tentacle Shield. Now, the next step from here is I'm going to close this out. The Whitebox Labs actually gives you a I2C example. And if you also go to the pH I2C sample code from Atlas Scientific, you get this sketch here. This sketch here is pretty simple. It has a default address of 99, which remember, that's what our default is. And then it's just really simple code that sends the command and then actually reads the address out. It gives you the ability to float the number, so if you want floating point integers, and then it just prints it to the serial screen. So this sketch, in my mind, is pretty simple if you want to, maybe once every 10 seconds, query the Tentacle Shield to get the pH. You can modify this sketch to do this. Now, it does mention in Atlas's website that they overwrote this code so that it definitely works for everybody on all the Arduinos. So I'm going to upload this sketch here, which is the default sketch from Atlas Scientific. Just let me get a second to upload. It's done. The serial is 9600, as you can see there. So we'll open the serial port up. I have to switch it to 9600. Also, you want to make sure you're at carriage return at the bottom. Okay, so the possible commands, according to the sketch, is either a C for calibrate or R for taking a read-in. So it says if a command has been sent to calibrate or take a read, and we wait some time so that we know we have it. So I'm going to just type an R. And you can see I get success, and it gives me 8.572. So that's what it was with the prior sketch. So that's pretty much it. It's very simple to use. In the future, I'm hoping to buy a Atlas Scientific EC probe setup. So on Atlas's homepage, it talks about the Whitebox Labs Tentacle Shield. You can actually click here for more information, so let's do that. It talks about what the Tentacle Shield is, how it works, and then you can buy it from Atlas Scientific for $115. Now, interestingly enough, in my mind, if you get the Tentacle Shield for $115, you can buy the pH Easy Stamp for $38. You can also buy a kit, which comes with a probe. Let me just click on that kit. It comes with the pH probe, the Atlas stamp, and then all the calibration fluid, and that's $150. Now, what I'm going to probably buy in the future is this Conductivity kit. And what that includes is a conductivity probe, the conductivity solution to calibrate, and then the conductivity stamp. And then I'll stick it on my Tentacle shield. And for $200, I'll have a complete electric conductivity kit. So you really can't go wrong for that. If you were to buy this kit through Reef Keeper or through the Apex, those kits there are at least $200. So I was just checking online. The Reef Keeper and Apex modulars are between $79 and $85 for the Salinity module. And then you have to still buy the probe, which is at least $115. And that does not include the solution. So for $200 for all of this, that's a really good deal. Let me go back to the workbench and I'll wrap up the video here. So I'm going to wrap the video up now. I'm going to talk about some things I like about the Tentacle shield, some things I'd like to see possibly offered as an alternative. First of all, the code is very easy to modify. As you can see, I'm using a port expander I2C LCD display. So this is a 16:2 LCD. It runs on I2C. And usually I have just power ground I2C, and I'm getting the pH reading. And I'll post this code down below. And the sketch just simply I believe it's 5 seconds, it queries the Atlas stamp and then gets to pH. And then the top line is the float, and then the bottom one is just an integer value. And I have just my cheap eBay probe connected to it. Things I like. I like the galvanic isolation. I like the 4 channels, and I like how it's very easy to use. Super simple to get running. Some things I'd like to see offered in the future. Perhaps maybe a double channel board, not necessarily a quad channel. I think for most applications, 4 channel might be a little too much. I don't really know what that's going to do for price. It could be that 4 channels and 2 channels almost is about the same price. But I feel like if they offered a 2-channel version, even if it was only $20 cheaper, it would probably still be worth it. Nevertheless, that's just one thing I'd like to see. Overall, very good build quality. I'm very impressed with the product. So anyways, I'm going to put this on the aquarium, let it run for a couple weeks, and then I'll bring back another video and let you know how it's been performing. Again, I'll post a code down below for what I have running. Anyhow, thanks again for watching. Please hit the like button. It really does help a lot. And look forward to you in the next one.